Hi guys, let's see, what did I do here? Oh, Chrome, okay. So I found the example 6.1 in the book here, and it's a pretty typical physics problem, is that it's very long, gives you lots of information. So this says that your kneecap is attached by a tendon to your quadricep muscle, and the tendon pulls at 10-degree angle relative to the femur, which is the bone of your upper leg, and the patella is also attached to your lower leg, which is the tibia, by a tendon that pulls parallel to the leg. And it says to balance these forces, the end of your femur pushes outward on the patella, bending your knee, increases the tension in the tendons, and both have a tension of 60 newtons when the knee is bent to make a 70-degree angle between the upper and lower leg. What force does the femur exert on the kneecap? All right, so here's kind of an image to go along with this. So this tendon, and I'm going to draw this free body diagram too. We did the other day, or a couple weeks ago, I guess I should say now. And then there's sort of this one going here. And those are absolutely not to scale at all, because this is like 10 degrees here. We do not know what that angle is, and we don't know what that force is. That's actually what we're going to try to find for both of those. And we know that this one is at 70 degrees. And this is both, being pulled. So there's some tensional force there. Okay. So now that and it also says that the tension, I can't write on the book, but the tension for both of them, 1 and 2, is equal to 60 newtons. Okay, so I'm going to kind of go off of the book now so that I have a bigger screen here, because this one was kind of a long one. Oh gosh, that made it like really big. Okay, so looking at your image now, you've got to separate these out into your forces in the x direction and your forces in the y direction. Okay, so we're just gonna write that force of the x is equal to tension 1 plus tension 2 plus force, and it's all equal to 0. And then our force in the y is tension 1 plus tension 2 plus the force is equal to 0. All right, now we can actually start to plug in some of these values. So see how as far as the tension 1 is concerned, if we're doing the x first, it's going in the negative x direction. So we can say, this is like for this one, when we're actually plugging in some negatives and actual values, we do negative tension 1 cosine 10, because we're doing the x and it is adjacent to the x-axis there, minus tension 2, we're still in the negative x here, cosine 70, and our force is actually a positive. And we have no idea what that angle is. It's equal to 0. Here. Okay, now for our y value. Tension 1 is now positive. So it's tension 1 sine 10 degrees. Minus tension 2 sine 70 degrees plus force in the y direction, sine theta, whatever that will be. Okay, now I'm going to kind of scroll down here. So now if we kind of set these up to where we're solving for the forces here. So we've got force cosine theta, and I'm going to move stuff around. So I'm going to move like this tension and this tension over to the other side. So tension 1 becomes positive now because I moved it over 10 degrees, plus tension 2 cosine 70. And you can do the same thing for your force of y your force y. So when you move this one over now, it becomes a negative. It's a negative. Plus tension to sine 70. Okay. Now, if I take these forces right here, okay, and cancel those out, and I flip this, so now I have sine theta is equal to negative tension 1 sine 10 degrees plus tension 2 sine 70 degrees divided by cosine theta. That's also equal to tension 1 cosine 10 plus tension 2 cosine 70. Okay, I just flipped it. Why did I do that? Because sine over cosine is basically like saying opposite over adjacent, which is tangent theta, which is equal to negative 1 sine 10 degrees plus tension 2 sine 70. I'm writing the same thing over again a lot. Divided by tension 1 cosine 10 plus tension 2 cosine 70. Well, I'm actually wanting to just find the angle at the moment, and then I can take that angle and I can plug it into the equation above and find the force. So if I am just finding the angle, then I need to get rid of the tangent, meaning I need to move it over to the other side. So I would basically be like dividing it, which is inverse tangent. So inverse tangent, I'm going to actually put in the numbers now. So you've got negative tension 1, and tension was 60 newtons, sine 10 degrees, plus tension 2, which was 60 newtons, sine 70, divided by 60 newtons cosine 10 degrees, plus 60 cosine 70. If you do all of that in your calculator, you should get 30 degrees. Okay, and now just go back up to the force of x, where we have this negative, and it really doesn't matter. You can do the force of x or the force of y. I'm just doing the first one. So the force of x was negative, I'm just going to write it out again. Negative tension 1 cosine 10 degrees minus tension 2 cosine 70 plus the force of x cosine theta was equal to 0. I can't write the 0. Okay, so we've got negative 60 newtons cosine 10 degrees minus 60 newtons cosine 70 plus force cosine 30 is equal to 0. So now if you solve for force, then you end up with, so now you're going to move stuff over. So you're going to move that over to the other side and move that over to the other side and divide by cosine 30. So you've got 60 cosine 10 plus 60 cosine 70 divided by cosine 30, which is equal to 92 newtons. And that is your answer. That was a long one. All right, so I'm going to stop the recording and start